Today we're going to review reaction types, and you would have done some of the reaction type stuff in grade 10. And there's basically 5 major types of reactions that we're going to see, and it will help us to know these types will help us to predict what the products will be in a reaction. So you may remember some of these terms as decomposition, synthesis, single replacement, double replacement, and combustion. So we'll start off with synthesis. Synthesis means you're just combining things. You're synthesizing, you're making something from a couple of things. We can also call it direct combination. So this is where you take 2 or more things and you combine them to make one thing. The general form would look like this. A and B makes AB, so the AB get together. Here's an example. So nitrogen and hydrogen gas get together and make NH3. Now notice it's not, if I put N2s and H2s, it's not N2H2. They have to go together based on the way they're either going to share electrons or the way their charges would work. So an example or a demo that I did in class is magnesium, metal, and oxygen gas. When they get together, they're going to form magnesium oxide, which is MgO. The reason why is Mg forms a 2+ and oxygen forms a 2-. So when they get together, they go in a ratio of 1:1. This is where balancing comes in. So basically the mistake I see all the time is students will put magnesium and oxygen and they'll say this. But that's not how magnesium and oxygen combine. They combine in a 1:1 ratio because of their charges. So to fix that, we need to balance. So I need to put a 2 there, which means I put a 2 there. So this is how we're going to balance those. We can't force the formulas to be what we want them to be. They are whatever they need to be, the way the atoms are going to get together, and we just balance the reaction after to make it all match up. So here's a real-life example. It's kind of an older one now, but Brad Pitt and Angelina Jolie got together, and the media was calling them Brangelina. So they combined to make one thing, apparently. Decomposition. So decomposition is just the exact opposite of synthesis. This is where you take a single compound and you're breaking it down into 2 or more simpler compounds. So you have like A, B, and they split up and they become A and B. So here's an example, 2KCl3, LO3 makes 2 KCl's and 3 O2s. Again, notice in this case, the way that it splits up, the O3 doesn't just go off and become O3. They decompose into what they're supposed to be. So like, let's even say if we decompose some water, so let's go H2O, I'm going to break that up. When water decomposes, it's going to break up into hydrogen gas, which is H2, and oxygen gas, which is O2. Notice that the number of oxygens has changed. That's okay, because we can go back and balance. So I'll need 2 waters to decompose, which will make 2 hydrogen gas molecules and 1 oxygen gas molecule. That's where the balancing comes in. We can't change the little subscripts to make it balance. So here's a real-life example again. So before Angelina Jolie, Brad was with Jennifer, and they split up, and Brad and Jennifer they were in Bennifer, and now they're single things. They're Brad and Jennifer. So with single replacement, this is where you can think of it as you have a couple and a single. So notice here's my single and here's my couple. B and C are together, and A is going to switch out one of the B or C's, either B or C. Now depending on what A is, if A is a metal, it will switch the metal. If A is a nonmetal, it will switch the nonmetal. So in this example here, I have sodium. So since sodium is a metal, it's going to switch spots with magnesium. And if you notice, sodium goes with hydroxide, and magnesium is now on its own. So that's kind of how this works. Let's think of another example. So let's do zinc metal and HCl. Well, zinc and hydrogen are acting like my metals here. So zinc and hydrogen are going to switch. So hydrogen is going to go by itself. So that's going to be H2, because that's what hydrogen is when it's on its own. And then zinc goes with chlorine, but it's not going to be just ZnCl, because zinc forms a 2+ and chlorine forms a 1-. So when I put them together, you need 2 chlorines. So we can go back and we fix that by balancing the reaction. So I need 2 HCl's to match up. Here is the real-life example. So we started with Bennifer, and then Angelina Jolie came along and switched out Jennifer. So notice the girls are switching spots. Again, it's either the metal switch or the non-metal switch. And the reason why is because we want positives and negatives to go together. If I did something like this, let's say I had NaCl, and let's put bromine gas here. Well, Bromine is a nonmetal. Notice this is kind of a single thing. It's not with something different. And this is a couple. So the bromine and the chlorine are going to switch spots. So the sodium goes with bromine, and the chlorine goes off by itself. Now notice the little subscripts have changed. Well, sodium's a 1 plus, bromine's a 1 minus, so that's why you only have NaBr. And chlorine is part of that Hofbrinkel we've been talking about, so that is why chlorine is a Cl2. We can go back and we fix that by balancing after the fact. So I need a 2 there, gives me my 2 chlorines, and I put a 2 there, and it gives me my 2 bromines, and then my sodiums are balanced. So metals switch metals, nonmetals switch nonmetals. Now, we can also have double replacement, and that's where you have 2 compounds and we're switching the positive ions, or basically we're switching partners. In this case, again, we always want metals to go with nonmetals. Positives and negatives attract, opposites attract. So when you look at this, think of switching your first elements. A and C will switch, so A goes with D and C goes with B. We want the metals to go with the nonmetal counterparts. So here's another real-world example, or kind of an analogy for it. You have Pink Panther and Black Eye, makes Black Panther and Pink Eye. Basically what you're doing is we're switching the colors. Black goes with Panther and pink goes with Eye. They just switch spots. So another example, this is the demo that I do in class, will be potassium, what was it, Ki, potassium iodide, and PbNO3, 2. When I put these together, we're going to switch partners. Now, the iodine and the nitrate don't go together because they're both nonmetals. K and Pb don't go together because they're both metals. They don't want to go together if they don't have to. So K is going to go with NO3. And off to the side, I'm going to go, well, K is a K plus, and NO3 is a 1 minus. So that's going to be KNO3. And Pb here is actually a 2 plus, and iodine's a 1 minus. So this is going to be PbI2. So again, notice that the little subscripts change, and that's okay because they go together based on their charges. So what I'm going to do is I'm going to go back and fix the nitrates and the iodines, and now I should be balanced. The last type of reaction that we talked about in grade 10 was something called combustion reactions. Now, lots of students will think that this is a reaction that anytime you're burning something. By definition, a combustion reaction is where we're reacting a hydrocarbon. So all combustion reactions will look like this. They basically have this general form. The only thing that changes is this hydrocarbon, and it's always going to be a hydrocarbon. Well, what's that? Hydrogens and carbons. You're looking at things like, in this case, this is propane. We're talking about gasoline. We're talking about butane, propane, methane, octane, all of those kinds of things. We're talking about alcohols and sugars. Basically anything that has C something, H something, and sometimes O's or OH's. So like CH30S is methanol. That's an alcohol. That would be a combustion reaction where you're burning alcohol. Another one would be like sugar, C6H12O6. Okay? That's a hydrocarbon as well because it's a big carbon chain with hydrogens and a couple oxygens. So they will always look like this. It's usually some sort of hydrocarbon and oxygen making carbon dioxide and water. Those are our reaction types.